Alright, y'all, welcome back to really what's going to be the rest of Chapter 6. I just drank like a quart of chocolate milk, so I'm a little bit groggy in my throat right now. Bear with me here. We're talking all about factoring, and I am looking at page 438 in your book if you want. Page 437, I actually think makes it more confusing than it ever has to be, so don't even look at that. Go right to example 1. If you remember this factoring stuff, and I want to say this every single time I'm going to say this in class today, that we're always going to multiply the first number by the last number and to get the number that we have to find for the middle. And in this case, 1 times negative 14 is actually negative 14. And then we say to ourselves, okay, what numbers are going to multiply to give me negative 14 that will give me negative 5? And in this case, well, it's 7 and 2 give me 14, and it'll give me negative 5 as long as I have negative 7 and positive 2. And that's my actual answer. When there's nothing in front here, when there's no a in ax squared plus bx plus c, that's what everything is coming from, okay? Then if there's just 1 there, then we can always just take the factors of this, and really, we just write out x and x, and this is how we do it. This is kind of a guess and check, or an AC method, which we'll get to in the next section. And I just put those numbers, negative 7, positive 2, negative 7, positive 2. And it doesn't matter if you put positive 2 and then negative 7. Either way, look, this is negative 7 and positive 2, which gives me negative 5. And negative 7 times 2 gives me negative 14. If we were to FOIL this back out, we should always get this as our answer. That's how you can kind of check it. FOIL it in your head. That's it. It is that easy for this section. Same thing here. Okay, let's start with, again, I've got a singular z here, so it's going to be z and z. 1 times 48 gave me 48. And the numbers that multiply gave me 48 would be like 1 and 48, 2 and 24, 3 and 16, 4 and 12. That's what we need here, because 4 plus 12 is 16. So negative 4 and negative 12 should give me negative 16 when I add them together. And a negative times a negative would make it positive 48. And that's it. That's our answer right there. Okay? It's finding those factors of that last term when there's no a. But in case we're going to do this for every single type of problem, multiply 1 times 48, 1 times negative 14. In this case, it's not in standard form. This is skill practice number 3. Okay? Skill practice number 3, I'm all the way over on page 440 now. If you look at example 3, it gives you a couple of examples, and it makes you want to write them in order first. We need to write this in order of ax squared plus bx plus c, right? So I'm going to start with w squared minus 5w minus 6. It's in descending order or standard form if you remember. And then 1 times negative 6 is negative 6. And the numbers that multiply to give me negative 6 and add to give me negative 5. Now that's a little bit confusing because a lot of you want to say it's negative 2 times negative 3, right? Because that will add up to give me negative 5. But a negative times a negative would make that positive. And that's not it, right? So instead, we're going to have negative 6 and positive 1, right? That will add to give me negative 5, and it will times to give me negative 6. This is one that if we were doing this in class, I would get some of you on this. Some of you would go with negative 2 and negative 3. Now, negative 6, positive 1, again, it doesn't matter if you go positive 1, then negative 6. Either way, that's how we factor problems, right? If I look at number 4 kind of leads me to kind of the next step of this. If you look at example 4, it tells you more of that as well. If you can find a GCF, then you want to take that out first. Always. Even if the GCF is negative 1. We don't ever want to lead exponent to be negative here, like a negative 1 here. So we're going to take a negative out of that one. We're going to take a negative out of that one. But for this one, there's not a negative take out. There's, well, first of all, it's not in order. So I'm going to write it in order. 2y to the 4th plus 30y to the 3rd plus 112y squared. And then I got to take out the GCF here, which is going to be 2y squared. And when I take a 2y squared out of each one of these, I'm left with, I'm actually going to write it out here. I didn't think I'd run out of room. 2y squared times, let's see, I divide the 2's out here, I'd be left with y2. I divide the 2 out to get plus 15y, because I'd have 3 here and 2 there, and I subtract to get 1. Here the y's would cancel. I would divide those to get plus 56. And that will factor to give me 2y times y and y, right? The factors of 56, because this is 1 times 56 now. Factors of 56, let's see, I got 1 and 56, 2 and 28, 3 doesn't go, 4 and 14. It doesn't give me 15 yet. Let's see, the most obvious one, 8 and 7. Yep, that'll give me 15. Cool. So it's just plus 8 and plus 7, because 8 times, if I multiply these out again, I get 8 plus 7 gives me that 15, and 8 times 7 gives me that 56, right? So that's my answer. This 2y is still a part of your answer. We talked about this before. The GCF still has to be there, okay? On this one, again, I'm going to take out a negative 1 here out of all of those. And if I do that, I'm left with x squared. Take out a negative 1 out of here, it becomes the opposite. Take a negative out of here, it becomes the opposite. And then I just factor that out, right? X and x. The factors of 12 are 1 and 12. 2 and 6 are 3 and 4. 3, 4 is how I'm going to get that. But to get a negative 1, the 3 has to be positive and the 4 has to be negative. And that's it for that one. Okay. Number 6. Boy, I really should have given myself more room here. The first thing I would do is, again, is there a GCF here? And there is. It's negative 3. I'm going to write it up here. Negative 3 times a squared minus 5ab plus 4b squared. And now I can see, well, 4 times 1 is giving me 4. I'm going to either have to use 1 and 4 or 2 and 2, and 2 is not going to give me this 5 here. So this is negative 3 times a, and remember what we said, it wasn't going to be 2 and 2, it was going to be 4 and 1. And of course, I got to throw that b on there as well. Now to get that negative there, right, this has to be a negative. Okay, now let's go back and again double check. This would be negative 4ab, this would be negative 1ab, and when I add them together I get negative 5ab, and a negative times a negative is positive 4b squared. Good. Okay, so it works. That's it. That's the answer. Okay. The last one, the factors of 28, so 1 times 28 gives me 28. I get 1 and 28, I get 2 and 14, I get 4 and 7. And no combination here is going to give me that negative 7. So when you get something like that, you write prime. And I am not above giving you an answer that is prime on a quiz. In fact, I think there's at least one on the quiz that you're going to get tomorrow. Okay. All right, so that is section 6.2. We are already 7.5 minutes in, so this is probably going to be about a 30-minute video, but it's going to cover all 4 sections here. So, moving on to 6.4. Again, I'm over on page, let me flip it over in my book here. Okay, I am on page 653, if you want to join me there, where I'm looking at example 1, and it's talking about the AC method. I actually think I do want to show you in the book what this is saying. Okay. Now, what the book is saying gives us an equation, 2x squared plus 7x plus 6. And I'm going to, the a is the 2 and the c is the 6. And just like I was doing on the last section, I'm going to multiply 2 times 6 to get 12. Right? Then I want to think of the factors of 12 that are going to give me 7. And the factors of 12 that are going to give me 7. Not 1 and 12. Not 2 and 6. But 3 and 4, I can get that to 7, but not negative. Well, actually, a negative times a negative will give me a positive 7. But they have to add, not negative. Negative have to be positive to give me a positive 7. That's why it's 3 and 4. Now look what they're doing. They're rewriting it. The first and the last term, the 2x squared and the 6, they don't go anywhere. All they're doing is taking that 3 and the 4 and breaking that 7 into it. So they broke it up into 3x plus 4x. Right? Okay. Now, from there, they group it. And we've done this before, group factoring. You can factor an x out of here, you're left with 2x plus 3. You can factor a 2 out of here, and you're left with 2x plus 3. And remember from last chapter, what they have in common is one factor, and what's left, the x and the 2, is their other factor. And then they just FOIL it back out to check it to make sure, right? All right, so let's look at what that looks at for our example here. Skill practice number 1 here. So I'm going to times 2 and 3. And again, that's a positive 3, so that gives me a positive 6. What are the 2 numbers that will add to give me 5, that multiply to give me 6? Well, 1 and 6 is 7. If I go negative 1 and 6, that will give me 5, but that won't give me a negative 6 here, and that should be negative. So what I need here is 2 times 3, right? 2 times 3 is 6, and it adds to give me 5. We're always looking for what adds to give me that. And now all I'm going to do is just rewrite this. This is 2x squared plus, again, we're going to split that 5 into these 2 numbers. You're going to have to see this a few times before it makes sense, but in the book there's multiple examples too. 2x plus 3x plus 3. Again, that doesn't change, that doesn't change, and we split this up into the numbers we found. 2x plus 3x gives me 5x, because now I can group that. The GCF of those two is a 2x. If I take a 2x out of here, I'm left with x, right? If I divide that by 2x. If I divide that by 2x, be careful, that's a plus 1. What can I take out of both of those terms? I can take a 3 out, and I'm left with x plus 1. Ladies and gentlemen, I am not going to give you a problem where you're going to have two different things in parentheses. If you do, it's not factorable, it's prime, right? If you get a problem like this, you cannot have two different things here. If you do, you probably misfactored it. Now look again, what they have in common, x plus 1 is one factor. What they have left, the 2x and the plus 3, is the other factor. I'm going to circle that a minute. But again, if I go to distribute this out, that's 2x squared, good. I get 3x plus 2x, which is why I can break it down like this in the first place. That's 5x. And 1 times 3 gives me 3. It works. Okay. Let's look at another one. This next one is not in order, so let's write it in order first. So 6w squared plus 13w plus 6. We multiply these outside numbers. 6 times 6. The AC method multiplies a times c, and I get 36. And 36, let's see, we get 1 and 36. That's not going to give me 13. 2 and 18. 3 and 12. 4 and 9. That's where 13 is. 4 and 9. So again, the first thing stays the same. You split up the 13 into 4 and 9. It doesn't matter if it's 9 and 4 or if it's 4 and 9. Because I wrote it first as 4 and 9, I'm going to split it up as 4 and 9. And the last term, well, that doesn't change either. And now you can group it. The thing that goes, that should be w, sorry. The first thing I could take out of both of those is a 2 and a w. When I divide this by 2w, I get 3w. When I divide this by 2w, I get plus 2. Plus, what can I factor out of both of those? Well, that's just a 3. What am I left with there? Well, it should be the same, and it is. 3w plus 12, because 3 divided into there gives me 3w. A 3 divided in there gives me 2. What they have in common, 3w plus 2 is one factor. What they have left, 2w plus 3, is the other factor. And that is it. Again, let's multiply it out. 6w squared, 4 plus 9, made sense, gave me 13. And 2 times 3 gives me 6 in the end. So there is the answer, right? For number 6, it's a little bit different. Okay, and we're only doing 1, 2, and 6 from this section. I will say that there is some more problems on 3 and 4, where 3 just talks more about like taking out a GCF first and then using the AC method. You can kind of see what they're doing in example 3, what they're doing in example 4, where they took out the GCF and then they rewrote it. You can try some of those on your own, or I can go through that with you. 5 is the same thing, except for on 5, I'm on page 456 now. On number 5, when I multiply 2 times 4, I get 8. And the factors of 8 are 1 and 8 and 2 and 4. And none of that adds up to give me 5x. That's where I was trying to talk about earlier. If you can't get it to work, then that's when it's prime. Okay. For this one, for number 6, okay, we've got a 4th degree polynomial. But it works the same way as long as it's 4, 2, 0. What I'm trying to say here is, instead of like w and w or x and x, here I'm going to not have y and y, I'm going to have y squared and y squared, but it works the same way. And I'm going to give you problems that work. So let's start this by doing the AC method. 3 times negative 8 is negative 24. And the factors of negative 24 are 1, 24, 2, 12, 3, 8, 4, 6. That's how I'm going to get it, 4 and 6. But to get a positive 2, that's got to be positive and that's got to be negative, which makes sense because I need a negative 24 anyway. Now again, break this down. 3y4. I'm going to break this into these numbers. Negative 4y squared plus 6y squared minus 8. And again, it doesn't matter if these are flipped, it just regroups differently, but you'll still get the same answer. The GCF of these is just a y squared, and I'm left with 3y squared minus 4. The GCF of these two is literally just 2, right? So I'm going to get 3y squared minus 4. Oh wow, look, they have that in common. There's my one factor, 3y squared minus 4. And my other factor, y squared plus 2, is what's left. Okay? Now, one thing they are not showing is what happens when there's a minus in between them. Man, I'm trying to find a problem. Let me look at what I did for your homework a minute. without showing you every single solution. When I'm going to take out a negative, 164, sorry, I probably should have been prepared for this already, but I want to make sure that you see this. Number 15 in your homework, take a look at this, okay? I'm going to zoom this way in. Oh, not that way though. Number 15, okay? So what I did, okay, give the camera a second to catch up here. Oh, maybe it's too close, the camera won't catch up. Alright, there we go. Alright, so here I've got a 4 times a 2, that gave me 8. But to get a negative 9, they both had to be negative, right? So I rewrote it, negative 8, negative 1. It didn't matter if I wrote negative 1, negative 8. I just wrote it this way for my work. Okay, and then what I see here is a 4W goes into both of those. If I just take out a 1W, or just a 1, excuse me, a plus 1, then I'm going to get W plus 2 here. I'm going to get negative W plus 2 actually. And then they're not the same. So anytime you see a negative right there, that's when you have to take a negative out. If the negative is in the middle, you have to take a negative out. Okay? So let me go back to our notes here. So if I had, I'm trying to think if there is, like for this one, if I had written this as 3y4 plus 6y2 minus 4y2 minus 8, then I would have, you can't see that, sorry. Alright, let's try this, okay? Alright, so I just switched these two around, and again, I see a negative in the middle. If I see a negative in the middle, I got to take a negative out here. But for these two, what I have common is 3y squared. I take that out, I get y squared plus 2. Right here, if I take out a 4y, or excuse me, just a 4, then I get negative y squared plus 2. And that has nothing to do with this, right? But you can see, excuse me, minus 2. But you can see they're opposite. So if I take out the opposite, negative 4, and again, anytime I see a negative in the middle, I want to take a negative out, I'm left with y squared plus 2. Right? Negative 4 divided by negative, I get positive. Now I have one term that they have in common, and what they have left is the other term. And this is what I'm trying to show you, that it doesn't matter the order either. You're going to get to the same result either way. Okay? Alright, that was another 10 minutes, so that I thought would be less time, but it is what it is. Alright, so we're moving on to section 6.5 now. If you want to flip with me over to, let's see here, page 458. We're going to do 1 through 3 here first. And what you'll see, these are called difference of squares. If you only see 2 terms, ladies and gentlemen, you need to always, so 2 terms means GCF or difference of squares. And sometimes, as much as it sucks, it's going to be both. But if I only see 2 terms, I'm going to see, can I square root both of those numbers? Yeah, I get a and I get 8. And that tells me the answer right there. It's a plus 8 and it's a minus 8. This is straight from the book. You'll see example 1 gives you y squared minus 25, which is y plus 5, y minus 5. And then you see example B there, which is kind of like our example number, or it's our skill practice number 2, which gives you a bunch of numbers. But again, can I square root this? Yes. And if I could square root that and square root this, which is 5q and 7w, then that's what I get. And one of them's plus and one of them's minus, and it's as simple as that. Okay. For this one, well, I'm going to have to take out a GCF first, for sure, because really I can't square root either one of these, and there's 2 terms, so I got to go right to GCF. And the only thing that fits here is 2, well, and m and n, right? And I'm left with, let's see, 49. When I take a 2 out of here, and m out of here would give me m squared, and an n out of here would just make that go away. A 2mn out of here, divide this by 2mn, right? That's minus 25. The m's and the n's cancel, simple as that, which gives me 2mn times, now again, it asks us to factor completely, right? So if I can now square root both of those, and I get 7m and 5, one's plus, one's minus. Simple as that. Now again, can I go back and FOIL these out to check them? Absolutely, right? Go back to this one. A squared, a plus 8 and a negative 8 will cancel, negative 64. A 25q squared, the plus 35wq and the minus 35wq will cancel out, negative 49w squared. Right here, I get 49m squared, 35m, negative 35 cancel, minus 25, and then I would, so that really gets me here, and then I just times it by this and it gets me back there. It works. Okay. All right, so right here, same kind of thing. Square root them both. Yep, cool. T minus 12, T plus 12. I'm putting that purposely because everything else I've been putting plus minus. You can write it minus plus, it doesn't matter as long as it's not minus minus or plus plus. This is not a minus sign. If it is not a minus sign, I can try GCF. Nope. And I cannot say this is a minus plus because a negative times a positive will give me a negative right there. If I say this was plus plus, well, then I'd have a 12t plus a 12t and give me 24t here, and there's no number in the middle. So when you see two numbers with a plus sign, that should just signify it. That's prime. And prime means it is unfactorable. You cannot factor it. Okay? All right, moving along. We've gotten through this a little bit quicker. Number 8, I'm skipping, let's see, I'm skipping example number 3 because we're just not going to do problems like that, but you've seen problems like that. It's fairly similar. Okay, if you can keep going on a w squared minus 9, you would. Okay, let's see here. Number 7 is a grouping problem. We just did that on the last set of notes, so I'm skipping by that. Example 5 shows you perfect square trinomials, which means, again, we think of 1 times 9 as 9. The numbers that multiply to give me 9 would be 1 and 9, or 3 and 3, which is going to give me 6 negative as long as they're both negative. Which makes sense, again, because a negative times a negative give me a positive. That works out. So there we go. X minus 3, which I want you to write as x minus 3 squared, right? Again, you can FOIL this out. You get a negative 3 and a negative 3 to give you a negative 6, and negative times a negative is positive. It works. This problem here, I've got, let's see, boy, there's a lot going on here. Can I GCF it? I can't take a 2 out of here, so that rules that out, or any even number for that matter. I know I can take a 3 out of there and there, but I can't take a 3 out of there. No even numbers. So 5, no. 7, no. 9, yeah. 9, yeah. No. What are the numbers that go into 16? Let's see. 2, 4, 8. No. Nothing's going to work here. I can't GCF this. So I've got to think about what is 81 times 16. And then you start saying, holy cows, that's crazy. 81 times 16. I don't know that off the top of my head. I don't even want you to know that. If it's that large, start thinking outside the box. It's probably one of these problems. And it is. Right? If you think about, this problem was a square root of both of those, and it was 3 and 3. This problem, if I square root both of those, let's get just a guess and check problem going on here at least. Right? And I'm going to go 81, the fact, let's see, so that's 9 and that's 4 if I square root them both. And if I go 9 times 4, I get 36. And if I do 4 times 9 again, I get 36. And those will add up to give me 72. That's it. 9w. Now look, if you look at example 5, it kind of breaks it down further. Except for, especially in part B, right? When I see perfect squares on the outsides, like the 25 and the 4, then that's when I want to start thinking that, man, maybe this is one of those perfect square ones. And that's, again, what I saw here. A square root perfect here, a square root perfect here to get 9w and 4. So 9w and 4. And now, do I want to go plus minus? No, because if I go plus minus, there's something that'll cancel here, right? If I go minus minus, then I get a negative here. But it's plus 36, and plus 36 gives me that plus 72 there, right? That's 81's w squared, and that gives me 16 on the end. Yep, that's it. Okay. Now, that gives us to the last section, 6, 7, which is why we do all of this stuff to begin with, is because we want to be able to solve these things. And the first few are just stupid easy, right? It's called using the zero product property, which says a times b equals 0, then either a equals 0 or b equals 0, right? To be equal to 0, one of these two would have to be 0, right? So to solve something like this that is in factored form, so in other words, it looks like any of these factors that we have done so far. Sorry, I forgot to circle this one. Okay? So this is already in factored form. All you got to do is set the factors equal to 0. You should all remember this, even if you took geometry last year. You'd minus 1 to both sides to get x equals negative 1. You'd add 8 to both sides to get x equals 8. And that's it, ladies and gentlemen. That's the answer. Now, check it. If I plug negative 1 in right here, I get negative 1 plus 1 is 0 times whatever. It doesn't matter, it's 0. If I get 8 here, 9 times 8 minus 8 is 0. 9 times 8, okay, yep, that's 0 too. It works, right? Both answers work. That doesn't mean plug in 8 here and negative 1 here. You plug in negative 1 to both to check. You plug in 8 to both to check. Next one, same thing, that already in factored form. So set 4x minus 5 equals 0 and set x plus 6 equals 0. This one is easy. X equals negative 6 because I would just minus 6 to both sides. This one gets students all the time. Students will tell me that the answer is 5 because they'll add 5 to both sides. But this is 4x equals 5. How do you solve a problem like that? You divide both sides by 4. So I get x to be 5 fourths and x to be negative 6. Now, do I want to go check that? Sure, why not? Negative 6 plugged in here would give me a 0. 5 fourths plugged in here. Well, that's 4 over 1 times 5 over 4, which would be 20 over 4, which is 5. And 5 minus 5 would be 0, so it does work. Okay? Same thing over here. You set the first term equal to 0, x equals 0. That is already solved for, ladies and gentlemen. Nothing to do there. You see 4x plus 9 equals 0. You would minus 9 to both sides to get 4x equals negative 9, and then divide to get x equals negative 9 fourths. Now again, do I want to check it? Well, if I plug in 0 here, that's 9, but 9 times 0 is 0. If I plug in negative fourths here, again, 4 over 1 times negative 9 over 4 gives me negative 36 over 4, because tops and tops and bottoms, which is negative 9, plus 9 gives me 0 here. Wouldn't matter what I have there. Okay, there's that. All right, take a breath a second. Let's take a look at skill practice number 4, which follows example 4 on page 474. And what you'll see here is, on example 4, is 2x squared minus 9x equals 5. We cannot ever solve any of these unless they're equal to 0. Ever. Ever, 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 ever. Okay? Don't try and solve these unless they're equal to 0. So how do I make this equal to 0? Well, you can see what they did on the other problem. They just added 24 to both sides. Now remember, those can't combine. It's just 2y squared plus 19y plus 24 equals 0. There is no GCF here, so I'm going to go right to the AC method. 2 times 24 is 48. And the multipliers to give me 48. 1 and 48, 2 and 24, 3 and 16. Yep, that's what's going to give me 19 right here. So I'm going to have 2y squared plus 3y plus 16y plus 24. Because again, the terms on the outside don't change, and the middle one gets split into what we found for the factors. Now we GCF it. This is just y, 2y plus 3. This is, looks like 8, goes into both of those, 2y plus 3, and that works out, right? The one we have in common, 2y plus 3, is one factor, and the other is y plus 8. Now all of that still equals 0, and why is that important? Because I don't want you to just factor this. You need to still solve this. Students get this wrong on the test all the time because they will get all the way to factoring and then stop, as if that's the answer. When it's equal to 0, that means I need to set 2y plus 3 equal to 0, and y plus 8 equal to 0. Here, of course, I get negative 8. That's the easy one, because I had minus 8 to both sides. Here, again, I would minus 3 to get 2y equals negative 3, and then divide both sides by 2 to get y equals negative 3 halves as well. Okay? All right, that's about as hard as it's going to get, right? Number 5, again, I just said you can't get it unless it's equal to 0. I'm kind of wrong, okay? If I make this so that it's not equal to 0, I get 5a squared minus 45 equals 0. I would GCF out of 5 and get a squared minus 9. And then I would factor this to 5, and you should notice this. This is a plus 3, a minus 3. And then you set each equal to 0. If I set 5 equal to 0, 5 is not equal to 0. That is an undefined solution. There's nothing to do there. When I set a plus 3 equal to 0, of course I get negative 3. When I set a minus 3 equal to 0, of course I get positive 3. And there's my answers there. Now the reason I said I kind of lied is because if I look at this problem to begin with, and I just divided 5 to both sides, I get a squared equals 9. And to solve a problem like this, you would just square root it. The problem is, when people square root it, they're just going to say it's 3. But when you square root both sides with a variable, you need to account for the plus or minus case. And here's why. Because when I plug in 3, 3 squared is 9. When I plug in negative 3, whenever we plug something in, it's always in parentheses. Is that still a true statement? Yes, it is. That's why it accounts for both the positive and negative case. Now, if you factor it, you won't make that mistake, right? If you get this far and you only give me 3, you're going to lose a point because negative 3 is also an answer. Okay? All right, so that is all 4 sections, just under a half hour. Well, by the time we get done, it's going to be just over. Okay? I don't know if you want to pause this here and copy this in. This is the homework. There is lots going on here, as you can see. Okay. Okay, I think that's good as it's going to get. Right here is the homework. This will obviously be posted on Google Class, or excuse me, on Canvas as well. The first two sections, 6.2 and 6.4, are the stuff that you're going to see on your homework quiz tomorrow. 6.5 and 6.7 is not going to be on the homework quiz, but it's definitely going to be on the test on Thursday. Okay? All right. So, a couple of reminders. Tomorrow we're going downtown. Looks like there's about a 50% chance of rain, so make sure you bring your umbrella, excuse me. Bring your walking shoes. Don't bring some heels or something dumb like that because you're going to be walking around a lot. We're going to meet at the normal time, and we are going to be meeting at Centennial Park, and that is at 250 Central Ave. It's between River and Central and between 10th and 12th Street. Reading number 5 is due tomorrow. Again, you will only be quizzed on 6.2 and 6.4 tomorrow. That is what you're going to take right before we go down for the project. For those of you that are not going to make the project, you'll take the quiz on Zoom like you always do. I'll be on my phone. And then on Thursday is your Chapter 6 test. So do your thing. Definitely do the work for 6.2 and 6.4. If you want to forego the 6.5, 6.7 homework to tomorrow, that's totally legit. But remember, I'm giving you a practice test tomorrow as well. Have a good day.